What is a structure? A structure is a member or a combination of member which can carry load is called a structure. Okay, if a structure do not carry any load, in that case we used to say that is a non-structural member. Okay, non-structural member. For example, a parapet wall that we used to provide at that top of a building. Okay, in the periphery of a building top floor. Okay, that wall, that parapet wall do not carry any load. Okay, so we used to call that as non-structural member. Okay. Now, what are the conditions a structure may satisfy? A structures need to satisfy equilibrium conditions as well as the compatibility conditions. Okay, equilibrium, unless if it's equilibrium, obviously there may be failure or there may be single member failure or whole structure may fail. Compatibility conditions also need to satisfy compatibility in terms of boundary conditions, strain conditions, that all need to satisfy. Okay, so structure need to satisfy equilibrium as well as the compatibility conditions. Okay, now question is that how we can solve the structures. Okay, if a structure is determinate, in that case, the equilibrium condition alone is sufficient to solve the structures. Okay, so for the determinate structures, whatever the unknown we have, in that case, our equilibrium condition is sufficient to get the unknown. Okay, now if the structure is indeterminate, in that case, we will not be able to solve that structure using equilibrium conditions only. In that case, we have to satisfy compatibility conditions as well as that equilibrium conditions. Okay, so depending on that, we have that two method. One is that force method and another displacement method. Okay, so now these two methods depend solely on which one we are satisfying first. Okay, if we are satisfying our equilibrium condition first, okay, if we satisfy equilibrium condition first, then we used to call that is our displacement method, okay, or stiffness method. If we are satisfying that compatibility condition first, then we used to call that is compatibility method or force method or the flexibility method. Okay, so basically a structures or structure or solution methodology can be classified depending on that which conditions we are satisfying first. Okay, so in the equilibrium method, okay, our primary unknown is the displacement. Okay, so since that our first unknown is the displacement, so we used to call this the displacement method. Okay, if our primary unknown are the force, then we used to call it as force method. Okay, since in the force method we first satisfy the compatibility condition first, so we used to call this a compatibility method. Okay, similarly in the displacement method we used to satisfy the equilibrium condition first, so we used to call that as equilibrium method. Okay, so while deriving that equations for that force method, while deriving the equation for the force method, we basically land up the flexibility terms. Okay, flexibility matrix or flexibility term, that is your 1 by k. So that's why we used to call that is a flexibility method. In the case of equilibrium method or displacement method, we used to land in the calculation we used to land up in a stiffness matrix term. Okay, that's why we used to call that as a stiffness method. Okay, so now we have two methods. One is that force method. Okay, another is the displacement method. Okay, now depending on that which condition you are satisfying first, okay, we're saying the same thing in different name. Okay, fourth method also used to call that flexibility method, is also called compatibility method because we are satisfying the compatibility condition first. Similarly, displacement method is also called equilibrium method or equilibrium method or stiffness method. Okay, so I hope you got some idea. Okay, if you want to just summarize it, okay, if you want to summarize it, you just try to write in that way that C, F, F, okay, that compatibility method, force method, or the flexibility method, and another way is that E, D, S, it's called equilibrium method, displacement method, or stiffness method. Okay, so basically these three are the same, these three are the same. Okay, so now you got idea what are the structures, what are the conditions a structure must satisfy, how you can solve a determinate structures, how you can solve indeterminate structures, and depending on that primary unknown, we also classify the solution methodology in two ways. One is that force method, another is the displacement method. Okay. Thank you.